Hansen. I've got a picture here for you. It's an aerial view of a bunch of crops in the Midwest, and you might notice there's a lot of circles in there. And so this lesson is on circles. And if we were to put a circle on a coordinate plane, maybe you have a coordinate plane for this or something. But if you were to put a circle on a coordinate plane, you could determine its x and y values on the circle, which might be kind of a handy thing if you're a surveyor or something. So let's determine an equation that gives us x and y values for a circle. If you had a triangle just like that, this is your x value here, that's your y value there. We'll call this our r, our radius, and r will never change. We could put a point right here. You would have a much smaller x and a larger y, but your r would stay the same. And so we're going to use the Pythagorean theorem to come up with a formula for a circle. So we're just going to say x squared plus y squared equals r squared. And you probably noticed that this isn't a function. It's got a y squared there instead of just a y. And of course it doesn't pass the vertical line test. But it does give us enough information to be able to plot points along the circle and determine an x value if you have a y value, or a y value if you have an x value. So let's see what we can do here. You might have noticed the radius on this particular circle is 3. So I'm going to put x squared plus y squared equals 3 squared, which is 9. Okay. And let's just take a look here and maybe plug in some possibilities. What if x is 1 unit, kind of like this one right there? If x is 1 unit, how long would y be? Well, it looks like it's getting close to 3 units, but let's just plug it in and see. So x is 1. What's y going to be? So we plug in 1, subtract it from 9, and we get y squared equals 8, so it's the square root of 8, which is about, I can't remember, I think about 2.41. You could also plug in a y value and get out an x value. If y is 2, you got 2 squared, x squared plus 4 equals 9, because 2 squared is 4. Subtract 4. X squared equals 5, and so x is going to be the square root of 5. So square root 5 comma 2 is another thing on this map. So y is 2 here, and x would be square root 5, which is a little bit more than 2. So hopefully that's helping you see how this works. Let's just add one level of complexity to this. I'm going to make another coordinate plane. This time I've got a circle, and it's not centered at the origin, at the point 0, 0. It's centered at the point 1, 2, 3, 4, and 1, 2, 3. So center is 4, 3. 4, 3 is the center. So if we wanted to move that center, if we wanted to translate that, we'd have to go down 3 and back 4. So I'm going to write this just a little different. Instead of x squared plus y squared equals 2 squared, I'm going to write it like this. X minus 4 squared plus y minus 3 squared equals 2 squared, which is 4, like that. And so that kind of helps us there. Now if we wanted a point on this circle, let's say we want the point when x is 2, 4, 6. Let's say when x is 6, could we find y? Well, let's just plug in. 6 minus 4, that's 2 squared, plus y minus 3 squared equals 4. So 4, this is 4 plus y minus 3 squared equals 4. Subtract 4 from both sides, you get y minus 3 squared equals 0. Square root both sides, and you get y minus 3 equals 0. And now you just add 3 to both sides, and y is 3. So when x is 6, y is 3. Okay, so that's about it for a circle. Let me just give you the complete formula. If that center point is called h comma k, it's x minus 3, nope, sorry, x minus h squared plus y minus k squared equals r squared. That is your formula for a circle. Hope this was helpful. Thank you.